Good afternoon, guys, and welcome to today's session where we'll talk about vSphere Metro Storage Cluster and how vSphere storage, Metro Storage Cluster, VMSC as we know it, how it helps in providing, how we can use VMSC to deploy traditional Oracle rack. Also, when we have this flavor of an extended VMSC over distances, how we can deploy an extended Oracle rack. Right? The standard disclaimer. I'll skip over that. So my name is Sudhir and I'm a staff solution architect. I joined VMware in 2012. Before VMware, I had a past life. So I was an Oracle DB and Oracle architect for close to 20 years. I worked for Fortune 50, Fortune 100 companies. That's the book that I have written along with my compadre in crime, Charles Kim. Take a bow. And let me hand it over to my another compadre, Marlon McNeil.
All right, thanks, Sudhir. I'm Marlon McNeil. I'm with the Yucca Group out of Albuquerque, New Mexico. And Sudhir and I have worked together on extended distance rack clusters on vSphere for several years now. So I'm enjoying that opportunity. I started out my career at Sandia National Laboratories in Albuquerque, New Mexico. Worked there for 5 years. That was a good time. And there are days, being an entrepreneur, after your 80-hour week, you're like, oh man, I would love to be back at the labs where I could call it at 40. Then subsequently moved to a software developer that was using Oracle for the back end of their software. So I learned Oracle by fire, pretty much, when I moved in there. Had 2 weeks to get spun up before we installed Oracle at a client site. And then saw probably 700 Oracle sites in my tenure there. So got a lot of exposure to a lot of ways to do things. Then we started the Yucca Group. I was one of the co-founders in 2011. So we just passed our 5-year anniversary. And it's been tons of fun, and we're going as hard and fast as we can. I also had the opportunity to be a technical editor on the book Virtualizing Oracle Databases on vSphere. So that was basically going through and making sure that everything worked exactly right. So I can guarantee you that everything in that book works exactly as advertised, because I did it myself a bunch of times. All right. Well, thanks.
Thanks, Marlon. So basically, as the agenda unfolds, we will go through some of the traditional cluster deployments, what an extended distance cluster really entails. We go into the concepts of storage virtualization, right? If you have to extend an Oracle rack, for example, across different sites, across multiple sites, not only is there a point of extending your storage across different sites, you also have to extend your network across different sites. So how do we do that? We'll also talk a bit about vSphere Metro Storage Cluster, extended Oracle rack on vSphere Metro Storage Cluster. We'll talk a bit about the case studies, and then we'll conclude and we'll take questions. So some of the key takeaways, right? Let's look at some of the benefits of deploying Oracle rack on vSphere, right? So not only do you have application level high availability, you have the ability of doing rolling patches, right? You also have workload mobility. You also have workload load balancing. And the best part is you have a greater uptime than if you were to deploy Oracle rack on physical. So let's face it, if you have Oracle rack on a physical architecture, right? If your workload is X, right, and one of the Oracle rack nodes or server goes down, you still have to sustain the same workload X. That workload never reduces, right? But then now you are running the same workload under a degraded condition, right? Think about it. If you were running Oracle rack on vSphere, all you have to do is, let's say if ESXi host 1 goes down, right, that virtual machine comes up on another ESXi server. So you are still able to meet your commitment. You are still able to meet your SLAs. Your workload still stays at X, and nobody is yelling at you or shouting at you, right? You're able to meet your commitment. Along with all the advantages that a traditional Oracle rack gives you, right? These are some of the advantages of stretching an Oracle rack across different sites. Not only do you have all of the goodness of a traditional Oracle rack, you also have site level high availability. What happens if a site goes down, right? Virtual machine comes up on another site, voila, you're able to sustain your workload, meet your SLAs. What if I have to do some kind of site maintenance? If I have to shut this entire site down, I can put my host in a maintenance mode. I can vMotion all my virtual machines from site A to site B. Everything comes up on this side. I do whatever I have to do. put it back on a maintenance mode, and everything comes back here, right? It's so seamless. And we'll also look at how VMSC helps with actually stretching an Oracle rack across distances with network virtualization and also with storage virtualization.
All right, thanks. So traditionally, when clusters first flared into existence, basically they're a collection of computing resources that have shared storage resources, just shared disk, and then an interconnect. And on modern clusters, that's typically a gigabit or higher of bandwidth that allows those nodes to share all of their resources. So memory and computing resources across that interconnect. And with that architecture, that allows them to scale out, so you can add more nodes, more computing resources to the same shared storage. And you can also scale up, so you can add bigger nodes. And if you're really inclined, you can do both. You can add more bigger nodes. In the early days, so first of all, in the beginning there was light. And shortly thereafter, there were clusters that looked like that. Right? And the first cluster that I ever did was actually at Sandia National Laboratories. It was a VAX cluster that had a 10 megabit, if you can even wrap your brain around that, interconnect between the two, and was distributed between two buildings. So we've been doing extended distance clusters since the word go. Ran some fiber optic, ran under the parking lot and under the drainage canal and up the other side. All right.
Thank you, sir. So we basically spoke about Oracle rack on vSphere. See, one point that I wanted to point out was this line. Typically, people come up to me and say, rack on rack. Right? You're running one clustering technology on top of another, right? Won't they impede with each other? Won't they trample on each other? Do you think they can coexist? And the answer is a resounding yes, absolutely yes. Because vSphere HA and Oracle rack are complementary technologies, right? We will show you a lot of case studies, a lot of customers running not only Oracle rack on vSphere, forget Oracle rack, traditional Oracle rack, even extended Oracle rack on vSphere. Some examples could be Telecom Indonesia that Marlon will be covering in his slides, right? So basically those guys are across 70 kilometers, and that's a telecom industry. So they are so latency sensitive, right? If they can do that, why can't anybody else, right? And the other aspect of running Oracle rack on vSphere, whether it's a vSphere cluster or a metro storage cluster, is provisioning, automating. And how many of you had to go through the process where I had to add another node to the Oracle rack cluster? Fine. I need to go get a server. Right. I need to make sure that the right BIOS is there, the firmware is there. I need to put the drivers in. I need to put the cards in. I need to install the operating system, make sure I patch it up, make sure I install Linux. And then after that, I need to put the Oracle binaries in. I need to run the add node.sh, all of the good things, and voila, the rack node is added to the cluster. But that takes time. Right? Here, all you have to do, your provisioning happens in minutes rather than in hours. And that's how an extended distance cluster looks like. See, this slide talks about traditional Oracle rack versus an extended Oracle rack, right? What actually sets them apart, right? Both of them provide high availability. One provides high availability within sites, within a data center. Extended Oracle rack provides high availability across sites, right? You are able to scale up horizontally and vertically on both the configurations, right? With the traditional Oracle rack, there is no stretching. Everything is within a data center. With an extended Oracle rack, yes, you are stretched across multiple data centers, and your stretching is both on the storage and in the network layer. Latency, 5 milliseconds. Everybody knows Oracle rack latency is kind of given 5 milliseconds. It's built in the traditional Oracle rack configuration. With the stretched Oracle rack or the extended Oracle rack, it's the same, but there is a lot of attention that you have to pay. With the Oracle rack, it's given as 5 milliseconds, but if you're looking at the vSphere Metro Storage cluster, the layer underneath the Oracle rack, that is 5 to 10, depending upon your license. So if it's an Enterprise Edition, 5 milliseconds. If it's an Enterprise Plus, 10 milliseconds. Look at the storage, the layer beneath the VMSC or vSphere Metro Storage cluster. It's 2 to 5. So for all purposes of argument, let's just assume Oracle rack, the latency is 5. So as you can see, the latency requirements are still the same, whether you do a traditional or you do an extended. Storage. With the traditional Oracle rack, you need a shared storage, right? With extended Oracle rack, you need a shared storage also, but you need to replicate that across two sites. Network. You need to have good network bandwidth in both the cases, right, it's local in case of traditional, and it's WAN in case of extended Oracle rack. What you need to keep in mind for the extended Oracle rack, the vSphere, vMotion, VLAN, you need to have a minimum of 622 megabits a second. That's a requirement. With redundant links, this is what we recommend. Layer 2 adjacency. You need to have layer 2 adjacency in both the sides. Traditional, it's built in, no big deal. But with the extended Oracle rack, it's required. You have to build that in. And with the traditional rack, you don't need there's no concept of a witness site. But with the extended Oracle rack, yes, I do need a witness site for arbitration. What happens if node 1 goes down? Or what happens if node 2 goes down? Or what happens if I have a network isolation or some kind of a cluster fencing operation? Who wins and who loses? That's this guy, the witness site. And if you look at any of, in fact, all major extended cluster deployments around the world, they will have some concept of the witness site. Site C.
Do you guys know what that's called when a condition happens where you don't have a witness site? Split brain.
Split
yes.
brain, yeah.
And split brains are a bad deal. Okay, thanks. So one of the things that is really necessary, they're kind of in review, there are 5 pillars of extended distance clusters that are, like Sudhir just explained, that set them apart from regular clusters. One is bandwidth. You got to have enough bandwidth between your 2 sites. 2, you got to have low enough latency. In this case, we say 5 milliseconds is safe no matter what. You can get away with a little higher. Talk about that in a minute. 3 is the shared storage you have to have. 4 is a third witness site, so you don't get a split brain. And let's see, we have bandwidth, latency, and the 5th one is you have to have layer 2 adjacency across between your 2 sites, right? Just like you do in one site, that's kind of a given. You just have a big old fat layer 2 switch, or maybe a layer 3 switch, but you can run layer 2 traffic across it. Well, in an extended distance configuration, you got to get that layer 2 so the ARP broadcasts go across between sites. We'll talk about that in a second too. The foundation of all of that stuff is the data communication that runs between the 2. That's why I kind of reiterated that. This is the key fundamental foundational component for that. So the speed of light, basically, a photon travels through fiber optic at 200,000 kilometers per second. So that means when you boil it down to 5 milliseconds, right? 5 milliseconds, a photon can go 1,000 kilometers in 5 milliseconds. Well, since we're dealing with round trip latency here, right? That means you fold that distance in half because it's got to go there and back, all right? And so that means that the maximum distance that physics will allow your sites to be apart is 500 kilometers, okay? So now the thing that makes that distance shrink is a bunch of different stuff. So one, you've got a data packet here, right? So your round trip latency.
That's a packet drop.
Packet loss. There we go. So round trip latency goes there and back, and it's going at the speed of light. But when you start adding store and forward hops into it, it adds a whole bunch of latency really fast. So you see that adds, I mean, it's kind of a lame object lesson there. But by the way, here's a broadcast storm. Oops. I dropped the packet here on this end too.
Exactly.
You're going to have to do a retransmit, right? Okay. So the deal is when you start adding circuitous cable distance in, when you start adding lots and lots of store and forward hops in, you can see it really takes, adds a lot of latency, so it takes your distance down a bunch. Okay? So Oracle kind of came up in one of their white papers with this rule of thumb that if you have 5 milliseconds latency, your cluster is stable no matter what. All right? Which it is. You won't have node evictions or anything if you have less than 5 milliseconds latency. And so they decided that no matter what, you could get that at 50 kilometers apart or less. And that when you have cross carrier hops and all that kind of stuff, you can still get that. Now, we've been actually working with a carrier in New Mexico where they have 2 sites that are, give or take a couple hundred yards, 200 miles apart, which is 322 kilometers. And because they have dedicated fiber with like 2 hops in it, they can get that distance in 5 milliseconds. And actually, there are 2 carriers that I know of that can do that. I'm sure that the other 2 that are big players there can do that as well. So if you want to get your cluster further than 50 kilometers apart, which is like 35 or 6 miles or something, talk to your carrier. And if they can't do it, go shopping for a carrier. But there are carriers out there that can get your nodes further apart than 50 kilometers. So you may have to relocate your data centers to the ends of their fiber to get that to happen, right? But it is possible. And that way you can, avoid a hurricane kinds of things and still have a site that stays up. Okay. When you start getting longer distances, though, I would recommend test the devil out of it first. And we'll talk about how to do that in just a second, for cheap even. Okay, so the use cases for extended distance clusters, 3 basic ones. It's high availability across locations. So what it is it's high availability. It's not disaster recovery. If you introduce garbage into one side, guess where that garbage is going to go in less than 5 milliseconds? To the other side, right? So you've got to have some disaster recovery in there as well. But the cluster is disaster avoidance. So if you see something coming, you can do site maintenance without disruption or site moving without disruption. So if you see the hurricane coming, you can migrate everything out of a site and not have any service outage because everything goes to the other site, right? Or if you need to replace hardware, do maintenance on your power grid, whatever, right? And you can also workload balance across sites. One of our case studies we'll talk about in a second, they run 12,000 employees against one side of an extended distance cluster, 13,000 against the other side of an extended distance cluster. And that works well for them. Now, yes, talking about bandwidth, those guys are a telecom provider, so they have all the bandwidth that you could possibly want. So that's not an object for them, like it might be for a lot of the rest of us. Okay, the misconceptions is, again, it's disaster avoidance as opposed to disaster recovery. You need something like Data Guard or DB Visit Standby or something like that to add disaster recovery in addition to your disaster avoidance. Okay, and again, the clustering is across all of your sites, not solely across just multiple components within a site. And this does cost you some money, right? Because you have to have shared storage and you have to figure out how to make that happen, and that doesn't come cheap most of the time. There are some less expensive alternatives we'll talk about in a second. And then you also need high availability or high bandwidth. And getting the gigabit Ethernet that goes over 200 miles is kind of expensive. All right. Now, one of the other pillars, the layer 2 adjacency, for a long time, that was kind of hard to come by. And you were stuck with carrier grade type services, right? And so both storage replication, to get your storage between both sides, and your interconnect on your cluster nodes, both require layer 2, in almost every case, require layer 2 adjacency. So what that means is that you can put half of an IP subnet over here, the other half of that same IP subnet over here, so that an IP address can float, a virtual IP address can float between rack nodes or storage nodes or between nodes on these 2 sites, all right? Otherwise, the cluster functionality starts to break down. You can get those, the carriers provide those. You can also get it with network virtualization. And a couple of ways that those can come about. The carrier grade ones are wave division multiplexing, MPLS. So you can pick that up from most of your standard carriers these days. And that actually has gotten quite a bit better and quite a bit less expensive lately. And then when we're talking about network virtualization, certainly NSX is one of the leading candidates. There's you can get layer 2 adjacency with that, and among multiple other benefits, microsegmentation being one of them if you're in a compliant type environment. Then there's VPLS, Virtual Private LAN Service, and that's bundled. And I just noticed that this slide is out of date. Last year, almost every vendor was talking about bundling it. By now, they've all bundled it in their current releases of stuff. So you can get VPLS with just about anything. Brocade, Juniper, Cisco, et cetera, they all have it. And then Cisco, if you have a Nexus 9000 chassis, OTV will do that as well. And then there's the ever omnipresent, ever faithful L2TP also will actually do the job. All right. So now I'll talk about storage virtualization a little bit and help meet the shared storage pillar of the extended distance cluster.
Thanks, Marlon. We need to turn this on. So basically, Marlon spoke about the network virtualization, which is one aspect of the extended rack cluster, right? The other aspect, the second aspect is the storage virtualization piece, right? So on a very high level, broadly on a very high level, there are two ways you could do it. One is host-based storage virtualization. An example of that is the Oracle ASM, where you have one device from site A, another device from site B. You put that in a normal disk group, right? And then you set the ASM preferred read failure group, right? So that reads go from the local rather than from the remote site. That's one way to do it. And the next slide would talk about the pros and cons of both the methods. The second way of doing it is the appliance-based storage virtualization. Basically, you're using EMC vPlex, or NetApp Metro cluster, HP Pure Persistent, IBM SPC, or even VMware vSAN, right? But what happens is, with some of these technologies, right, especially with the host-based virtualization example, they are storage agnostic. Even EMC vPlex is storage agnostic. You can use heterogeneous storage arrays beneath the EMC vPlex, and all you have to do is it presents a virtual volume which gets synced across two sites. IBM SPC does that as well. And the best part is, with storage virtualization, you are able to abstract the storage from the hardware. It allows flexibility in the location of the storage as well. Storage virtualization over extended distance. So as Marlon said, the latency requirements are exactly the same as of an Oracle rack cluster interconnect, right? Typically, when we were to go with a vendor-based storage virtualization method, you would require matching vendor appliances, right? You would require, if you want to go with an EMC gear, it would have to be an EMC on this side, an EMC on this side. If it's IBM, it has to be IBM on this side and IBM on this side. And typically what happens, first you sync it up, you ship the seed onto the other side, you do a full sync between the local and the remote, and voila, once everything is set up, basically, then you start shipping the change rate, the data change rate. And some of the data change rate that could be bandwidth intensive, it completely depends upon your workload. It depends upon your data. It depends upon your rate of change of data as well. What are some of the benefits of storage virtualization, right? So basically, you are able to replicate these volumes, both sync and async. Example of an async is EMC vPlex Geo, right? And the use case is an extended distance high availability cluster, right? You're also able to create storage pools from heterogeneous storage. Example, if you were to use EMC vPlex VE or IBM SPC, you are able to do that. You also have virtual appliances like vPlex VE available that you could use. And the best part, you are able to extend the useful life of your storage, and the data migration, that's non-disruptive. So there are a lot of benefits that storage virtualization bring to the table here. And like I said before, if you were to compare the host-based versus the appliance-based, with the ASM way of doing it, I'm going to take ASM as an example here. With the ASM way of doing it, you would see that you would require extra CPU usage because it's the ASM that does the actual mirroring for you. But wouldn't that be nice if you were to take that extra CPU usage and say, ASM, let's not ASM do it, let the storage do that for me. So you're basically giving that overhead over to the storage. And we already spoke about the need for the third site. ASM needs a third site for the voting device. And also, if it's vendor-based, you require a site C, the witness. Spoke about the ASM preferred read failure group. And yes, you need the ASM fast mirror resync, but this group has to be set to normal in case of Oracle ASM.
Now, to do justice to some of the storage vendors, the storage replication appliances, some of them are becoming storage agnostic, where they'll accept a nice SCSI target on the back end.
Absolutely.
Right, and so vPlex VE will do that, SVC will do that. Those are the two last time we really dug into this that would do that. Yep. There may be more by now, but that makes it so that you can use any storage on either side, and you can use anything that can produce an iSCSI target. Off you go. So
thanks, Mala. And that's typically what, if you were to go with the host-based virtualization, this is what it looks like. ASM is taken as an example here, versus the appliance-based. vSphere Metro Storage Cluster. People think that, you know what, vSphere Metro Storage Cluster is a product. No, it's not a product. There's no product called vSphere Metro Storage Cluster. It's a concept. You're basically taking the same vSphere cluster, stretching it across distance, and you're saying, voila, that's VMSC, vSphere Metro Storage Cluster. So basically, you're able to combine synchronous replication with array-based clustering. It's typically deployed on a metro or a campus-based data center. And again, Oracle RAC is not disaster recovery. So the best part is I was in Europe, right, when I was talking to a customer, and believe me, the whole argument went back and forth like an hour and a half, where he kept saying, no, this is disaster recovery. I have Oracle RAC stretched across 2 sites, right? And I am, this is a disaster recovery situation. Even though I said, and what Marlon said, it's garbage in, garbage out, right? I put garbage in here at some point of time, 5 milliseconds, garbage comes out this way. It's not disaster recovery, it's disaster avoidance. But eventually I lost. I couldn't fight with them, but of course I lost. But yes. And using the VMSC topology, you have the capability of migrating a virtual machine between sites. So we spoke about workload balancing, right? We spoke about workload mobility. We spoke about high availability. We spoke about site maintenance. We spoke about site high availability. So pretty much you're able to get everything if you were to deploy an extended Oracle RAC on vSphere Metro Storage Cluster. And these are some of the latency requirements for vSphere Metro Storage Cluster, some of which we've already gone. So like we mentioned, if you have an Enterprise Edition, it's 5 milliseconds round trip time. With Enterprise Plus, you can go up to 10. You do need a minimum of 622 megabits a second for the network bandwidth. Redundant links is what we recommend. Layer 2 equivalence, absolutely, for VM kernel and also for the VM network traffic. And the ESXi management network requires a maximum supported network latency is 10 milliseconds. But keep in mind, right, even though Oracle RAC is 5 milliseconds, you have VMSC that could either go 5 or 10, and storage can either go from 2 to 5. For all matters of discussion, for all sake of argument, we're saying 5 milliseconds when it comes to the application. Up to 50 kilometers, it's stable. Up to 100 is possible. Beyond 100, it's a real stretch. You have to really test it out. Even before you guys start on this journey where you were to deploy an extended Oracle RAC on VMSC or vSphere Metro Storage Cluster, what we highly recommend is you check the hardware compatibility list. You check the list and see, you know what, is this particular appliance, is that compatible with what hardware gear I have in shop? And if not, make sure that you have compatibility across all hardware appliances. So this, I think, is an example of deploying extended Oracle RAC on vSphere Metro Storage Cluster using host-based storage virtualization. That's using the automatic storage management, the ASM. So basically, we have a third voting file that's on a standard NFS mount on a third site. And yes, the recommendation from Oracle is put the NFS voting file on a dedicated server that belongs to a production environment. So basically, you have a concept of a third site here. When we look at the vendor-specific storage virtualization, and Marlon is going to go over it in a couple of seconds, you would see that's the same concept of Site C, where you have a witness. So be that IBM SVC, be that HP Pure Persistence, or be that even VMware vSAN, or even be that EMC vPlex, you would see a concept of a third site, a witness site for arbitration. Go ahead, Marlon.
Okay,
thanks.
Thank you. All right. So there, just to run across a few of the technologies that will actually replicate storage between the two sites, or multiple sites if that's what it takes. And this list is by no means comprehensive, so just disclaimer on that one. We discover new technologies that do this stuff all the time. So this list is evolving as we go. First of all, we have EMC vPlex. And notice one of the pillars, one of those 5 pillars of extended distance clusters is the third site, the witness site. And you'll notice that every one of these requires a witness site of some sort or other. Okay, this one here, some of them have VMs that just a VM can run, like an OVA, and you can deploy that anywhere. Some of them require actually a physical piece of hardware controller with some special disks attached to it. The SVC is that way. It needs a third piece of IBM hardware, things of that nature. So if you'll pay attention to each slide, they each have one of those. So this is vPlex. vPlex VE also is easy. You can download vPlex VE for free, and we've got that running in the lab. So you need a couple of CPUs to make that work, but you can download it and mess with it yourself. NetApp Metro Cluster, pretty much same deal. It'll replicate your storage across both sides. Some of these use fiber channel to replicate between. Some of them use an IP network. So it's kind of, depending on what you already own, take a look and see if that'll support distributing your storage across multiple sites. HP pure persistence, same deal. You can notice there's the quorum witness right there. And IBM SVC, and they have the same basic deal that was I described to you a second ago, where you have to have an IBM storage array at a third site. That was as of my interaction with VMware, or with IBM about 10 months ago. So they may have modified that since then, but that was the case less than a year ago. All right.
Now let's talk about our very own vSAN, virtual SAN. So basically with the virtual SAN 6.1 hybrid, right, and I'll go a bit into the virtual SAN as well, hybrid, we were able to deploy an extended Oracle rack cluster on a stretched virtual SAN 6.1 hybrid configuration. And this is what the deployment looked like, right? So basically it was a 4-node server, 2-socket, 20 cores each, 512 gigs of RAM. We deployed a 4-node Oracle rack, that was 11GR2, 11204, 8 vCPUs, 64 gigs of memory, that was the database size. And let me take a moment and talk about virtual SAN. So the concept of virtual SAN goes like this. It's a bunch of ESXi servers, and it's a hyper-converged infrastructure where the compute, the memory, the network, and the disk is all within, right? It has a concept of multiple disk group per host, right? So every ESXi server will have multiple disk groups, and every disk groups will have multiple disks. Key differentiator between hybrid and all-flash, and basically I may be missing a couple, but the key differentiators are, with hybrid, there are 2 levels of tiering. There is a cache tier and there is a capacity tier. The cache tier is for read and write buffer. The capacity tier is data persistence, right? So if you were to look at the disk group, every disk group, it has 1 SSD and 5 magnetic devices. So basically this SSD is for read and write caching, right? And the HDD is for data. So that's the hybrid model. This configuration, we had 4 ESXi servers with 2 disk groups, right? And with the all-flash, the difference here is with all-flash, not only do you have features like deduplication, compression, erasure coding, which is your RAID 5 and RAID 6, and you also have checksum. The capacity tier is no longer magnetic, it's SSDs. In that case, what happens is the cache tier, which was used for read and write in the hybrid configuration, now it's no longer used for read because you're able to read from any of the capacity disk. It's used mostly for write. So when you have to destage write, you write to the SSDs, which gets destaged at some point of time to the capacity disk. But that's the key notable differences between your virtual SAN hybrid version versus virtual SAN all-flash. So there is something called virtual SAN policy, and this policy applies to the entire virtual SAN infrastructure. FTT stands for failure to tolerate. How many failures can I tolerate? So for example, if FTT is set to 1, if I can tolerate 1 failure, I need 2 copies. If I can tolerate 1 failure, I need 2 copies. So the equation is, if FTT equals n, number of copies equal n plus 1, right? And that's how it does redundancy for VMDKs. Virtual SAN is an object component model. It's an object component model. Every virtual machine is an object. Every VMDK is an object, right? So you're able to provide software level mirroring, right? It's not a hardware level mirroring, software level mirroring. Number of disk types was set to 2. OSR stands for object space reservation. So you're basically saying we want to reserve 100% space for those VMDKs, the virtual disk, and we left the other SAN policy metrics or the parameters to default.
Sudhir, one thing that Sudhir and I discovered a couple of days ago is our friends here at Otto have a neat device that will take fiber channel storage and will present it as eSATA LUNs, or well, SATA LUNs. SATA LUNs up to an ESXi host or anything else, so that you can take your old fiber channel storage and convert it into vSAN.
I don't want to steal your thunder, but definitely, you guys, that's a cool concept. That's a very cool concept, and I think that will help customers, right? If they have a vSAN, it's bring your own vSAN, bring your own SAN, right? If you already have an existing SAN and you don't want to throw that away, why not? Let's make use of your appliance, right? So that's a very good use case. But this goes back to the same discussion of traditional Oracle rack versus the stretched Oracle rack. So basically, you have all of these features, right? You get workload sharing between sites. This is within sites. This is between sites. High availability. It's local to the site. It's between sites. Site maintenance. And yes, and this was the Oracle extended rack on virtual SAN stretch cluster. It's the same slide as before. I'm going to skip over this one. This is an Oracle rack disk layout, right? My apologies for the slide up there. Right. So basically what happens is when you deploy or when you use VMDKs, virtual disk, to set up an Oracle rack deployment, there's a concept of multi-writer. And the concept goes like this, right? When you create a virtual machine and you add a VMDK or you create a VMDK for the virtual machine, that VMDK is exclusive to the VM. That virtual has an exclusive lock on the VMDK. Now when you say, hey, I want to share that VMDK among multiple virtual machines, you would have to convert the lock from an exclusive mode to the shared mode. And that's what this multi-writer does. So basically what multi-writer tells is, hey, ESXi, hands off, right? Let the Oracle clusterware take care of data concurrency. Let it manage everything within, right? You just provide me the compute, the memory, the network, and the storage. And basically by doing this, you are able to share your VMDKs across multiple virtual machines, across multiple ESXi servers. And that's the KB article for setting up multi-writer on virtual SAN. The one for setting up multi-writer on vSphere Metro Storage Cluster, or even a vSphere cluster, is 1034165, if my memory serves right. And if you look at both the KB articles, the steps for setting it is exactly the same. There is no difference. And that's the paper that we released December 12th, 2015, last year. That basically has all of the metrics, all of the tests that we did, what benchmarks we got, what was the performance. And as part of deploying the extended Oracle rack on vSAN stretch cluster, we were also able to provide business continuity. We use Oracle RMAN. We were able to provide disaster recovery. We used the physical standby database. And again, the physical standby database was on another vSAN cluster, some distance apart. Let's have a look at some of the case studies. And this is for the host-based storage virtualization. I'm going to hand it over to Marlon. Take it over.
Okay, thanks. So this is kind of an interesting case study. This is a watershed case study in the history of the Yucca Group. This is when we discovered that real application clusters could be nicely virtualized on VMware. The 17th Judicial Circuit Court up in Northern Illinois, in Rockford, Illinois, Winnebago County, basically had an extended distance cluster set up. A physical one that their engineers and I co-built with them, and we were getting node evictions like once an hour, or if we were lucky, once every 2 or 3 hours, right? But it was pretty ugly, and we could not, for the life of us, figure out what was wrong. And one day we decided that we needed to do something to build a model of it, mock it up, so we could figure out what was wrong with the real one, because we couldn't take it down. It was in production, but it was just not doing it. And as I looked around the lab, I didn't have enough material to do really a mock-up of it, a physical mock-up. And then I noticed that there was a server sitting on the table over there that I hadn't racked yet, that had enough memory that we could virtualize every one of the components there, including virtual SANs, right? So we just used OpenFiler SANs to mock up their EqualLogic SANs. And we built ourselves an extended distance rack like we knew what we were doing. And it didn't take very long for us to start eliminating components because we knew everything was the same, and we matched the configuration till we narrowed it down to some buggy HBAs from a vendor who shall remain nameless, so that Anyhow, once we got the HBA swapped out, then life was good. And it's been rock solid for about 7 years since then. And so we're fixing to actually upgrade it to Oracle Enterprise Linux 7.1 here next week. But that really, and what we did there to replicate their storage was we used the virtual iSCSI SANs, and that allowed us to replicate the storage across their interconnect using ASM disk groups, right? So we had this SAN produced data 1 and FRA 1 and vote 1. The SAN over here produced data 2, FRA 2, and vote 2. And then we had a third SAN of the third site, again, the other pillar of extended distance clusters, that had an iSCSI target that was vote 3. So we put the 3 voting disks in one disk group, and then FRA 1 and FRA 2 in a disk group, and data 1 and data 2 in a disk group, cross-connected them, and we had a storage, an extended distance rack cluster over about 1 kilometer. And that really turned us on to what could be done. So from there, we took it and ran with it. That's kind of an example of how it looks. And of course, we had the third voting set right there that was in a third building across the street from the other 2 data centers. And then had virtual SANs everywhere. Was providing storage via iSCSI. All right. And if you are interested in the details of any of these, holler afterward, and we'll be happy to give you all the information you'd like. Then the next case study we've got is using appliance-based storage as opposed to host-based storage replication. And this one in particular is using EMC vPlex. This was we did work with Telkom Indonesia. Last I checked, they were global 786, global 780 something. So a very, very large company. These are the guys who had 12,000 employees at one site and 13,000 at the other site. And they basically are 70 kilometers apart. They have all the bandwidth that they want because they own the fiber. And they needed the load balancing as well as the high availability. These guys used, they had EMC VNX arrays at both sites, and they used the vPlex hardware appliance to replicate storage back and forth between their 2 sites. And then from that rack cluster, they used DataGuard to replicate all of their data off to a third site that was a few hundred more kilometers away than that, so that they had some disaster recovery in addition to their high availability. So they used EMC vPlex. Their architecture looked very, very much like that. Here's how their architecture actually looks in practice. Right, about a year ago, they had 4 clusters at each site. Since then, they have been, or 4 nodes. They had an 8-node cluster, 4 nodes at each site. They've been upgrading that. The target is to get to 12 nodes at each site. And then, of course, here's their disaster recovery site at a third site, completely separate. But they have layer 2 using Cisco OTV. They have their ESXi cluster stretched across the top of that, and then their rack cluster on top of that. So they're protecting all of their applications with the ESXi cluster, and then their database with rack on top of that. So they have a very, very high availability implementation. Okay. And if you're interested in how the hardware nuts and bolts look, that's it. So they've got their VNXs there. Their VMAXs, I'm sorry. And then their SVC, or their vPlex rather, that does the metro storage cluster that runs all their data across between sites. Yeah, and they're about 1,000 kilometers to their disaster recovery site. So they've got it a ways from where a typhoon would hit both places at the same time. Okay, IBM SVC.
Go ahead.
These guys here, we didn't personally work on these, but we were asking around, and our friends at IBM said, "Oh, hey, we know about this." And so they provided us with a case study where Fritz Winter in Germany had also done a metro storage cluster type arrangement with using IBM SVC as the storage virtualization layer that replicated the storage between their 2 sites. Okay, and there's kind of how their hardware looks. So using IBM storage, of course. And then violin memory, actually violin memory has replication built into their arrays. And so they didn't want to disclose the client, but they were happy to share this architecture. So the violin memory, which is all flash at this point, so needless to say, this thing was very, very fast. Wonder what happened. I must have. Well, anyhow. Well, yeah, disaster. Where's our other node on our extended distance cluster, right? I'm not sure. That's a fine question.
Did you press somebody?
I don't know.
That's a single point of failure.
That's right. So, at any rate, those guys have a nice, highly available.
Black slide in here. Or it went black or something. That was weird.
Oh, wow.
What slide were you on? I'm sorry.
Yeah, that was the one, yeah.
The Fritz Winter? Or the violin.
Okay.
Yeah.
There you go.
Okay.
It looked like you had a black slide.
Cool. Thank you. Huh.
Thank you.
All right. Appreciate it. So, yeah, the violin worked nicely as well, and it was really, really fast because it's all flash on both sides. So they not only had high availability, but really good performance as well. And these days, you know, there's Extreme IO from EMC. You can get all flash arrays from NetApp. You can get all flash pretty much anyhow you want. And you can even use some of the newer vendors like Tgile, Pure, Tintry, those guys, and put an appliance like SVC or vPlex in there that's storage agnostic, and then you can use kind of hybrid configurations of this as well. Now we have a real live case study. Deborah Kearney in the back, would you stand up kindly? Deborah is the Chief Information Officer of CU Anytime in Albuquerque, New Mexico. And she's been the driver behind an extended distance cluster that is protecting their management of their fleet of automatic teller machines. Deborah, would you take about 30 seconds and just kind of explain what you guys are up to?
Yeah, can you use the mic, please?
Certainly. We just deployed an extended rack cluster over hyperconverged infrastructure. So we have SimpliVity OmniCubes, and we are running our ATM monitoring and cache allocation system on that.
Okay. All right. Thank you. And so when we started working on this project together, turns out that they already had 2 data centers. They already had a data communications line in between, and they already had actually layer 2 adjacency set up with Cisco OTV, or not OTV, with L2TP on their Cisco network gear. So, and they had very similar needs, 0 RPO, and as the smallest RTO as we can configure their application servers to deliver, right? They had only, but check this out. So here, this one is where this gets interesting. Is this one, they only had 50 megabits instead of a gigabit. But, well, there's a trick to make that work, and I'll tell you about that in just a second. And everything here that was interesting, since they're PCI compliant, even though they're not passing any PCI data through any of this, they have to work inside a PCI compliant framework because they're dealing with financial transactions. And of course, so their framework, policies and procedures and everything were already built around Windows. So this entire thing is built on Windows Server 2012 R2. And basically, as we look at it, it was pretty clear that the way to provide them the SLA, the availability that they needed, with the performance that they needed as well, was to leverage those 2 sites. And we put one rack node, one virtual rack node at one site in a VM, a second virtual rack node at a second site in a VM, and then we have a third disaster recovery entity. And that actually, at this point, goes on one of the 2 pieces of physically licensed Oracle hardware. So those are both ESXi servers. We just licensed the hardware on those 2 ESXi servers, or utilized the storage coming off the SimpliVity array, which is very fast, by the way. And then we use dbvisit standby. And you can see kind of the nuts and bolts of how that went together. We have site 1 with an array of 2 SimpliVity OmniCubes. Site 2 has 1 OmniCube in it. So you have Our virtual SANs are hosted on the OmniCubes because they don't have to worry about licensing. And then we have a separate compute server at each side, which were servers where we P2V'd the functionality off of those servers onto the OmniCubes, right? So then we had 2 extra pieces of hardware laying around that were less than a year old. And so we were able to get some nice fast hardware, added a little bit of memory to it, and just called those dedicated compute nodes, added them into the cluster, the vSphere Metro Storage cluster, and away we went. And then, so those have the rack nodes right there, rack node right there, and then the disaster recovery node runs on the same physical hardware, so it operates under the Oracle licensing constraints. And we're using Oracle SE2 12102, which has rack bundled with it and ASM bundled with it, so we're using ASM disk groups to replicate storage between the 2 sites, so which was fall off a log easy to get the storage replication to come together on that one. And there are some of the details. Again, the layer 2 adjacency with Cisco L2TP. We're currently looking for a 3rd site to put the 3rd voting disk at. Haven't decided what to do with that yet, whether it goes to AWS or another physical data center somewhere or something. We'll figure that out. But it's going to go to a 3rd site so that they'll have the availability that they need. And here is our disaster recovery. We're using dbvisit standby to replicate from the rack nodes over to the 3rd site. Now you might ask, how did we make it work with only a 50 megabit interconnect? Super good question, right? Because normally that would just barf and die. Pardon the grosseria there. What we wound up doing was we decided to have a service, an Oracle service, only point to one of the database instances. So although there are 2 instances, there's one at each site, so that the storage can replicate between sites, only one of those instances is active. And so everybody hits the one instance. That way, there's no cache fusion traffic going to the other instance that nobody's hitting. Right? And that's the shared memory between the Oracle nodes. So the cached blocks that came off of storage, they don't have to travel across that interconnect. So the only thing that goes across that 50 megabit interconnect are just the writes that come to the ASM disk group, because all the reads come from the local disks. So we had to set that up using the ASM preferred read failure groups parameter, right? And then just the Oracle cluster registry overhead that goes back and forth, that keeps track of what node or what cluster resources are where, basically. And so there's enough bandwidth there, and it's low enough latency because it's 1 millisecond back and forth between the 2 sites. They're only about 6-ish miles apart as the crow flies. Are just downtown in a data center down there. And so with that low latency, but that low of bandwidth, we're still able to get the cluster to work correctly over 50 megabits. And then, of course, if something ever fails, the service will point to the available instance at the other side, and of course the cache will have to warm. So performance will take a hit because there's nothing in the cache on the other side, right? But the deal is it's still available, and we've still met the SLAs, 0 RPO and a few seconds RTO for the application servers to fail over. And if you guys would like to ask Deborah any questions, she's right there and will be available in the hallway afterward. Okay. Now, if any of you guys are interested in figuring out if your proposed configuration will work, you can test this all lock, stock, and barrel in a lab. You have to use ASM disk groups because, well, actually you don't, and I'll tell you why in a second. You can either do ASM disk groups, just virtualize some iSCSI SANs either off of Windows or Linux or OpenFiler or FreeNAS or whatever. You can see right here, basically what you do is you set up 2 vSwitches in ESXi, and then there's a host of WAN emulators that you can get. My favorite is WAN-M because it's fall off log easy. The instructions on how to use it are a page and a half long, and you just boot it off an ISO, It works. You connect one NIC to one virtual switch, one NIC to the other virtual switch. You tell it how much bandwidth you want, how much latency you want, how much packet loss you want, and it runs. And then you can put your rack nodes, connect your rack interconnect to the vSwitch over here, your other node interconnect to the vSwitch over here, and then you can simulate your WAN latency in between. Now, if you want to use a storage appliance, you can use vPlex VE. That's also free and downloadable. It's granted the free version is I don't know what they call it, hobbled. It doesn't have as much capacity as the full version does. However, you can set that up in the lab as well. It comes in an OVA format that you can load on your virtual machines. So then you can set up a cluster and you can say, I want to test this distance. I want to test 7 milliseconds with my load. And then you can use either Oracle Real Application Testing to replay a production workload. You can also mine a production workload with HammerDB, which is an open source tool. And you can replay that. Or you can use just a standard load generator, which there are a gazillion of. Right? That would be Swingbench, HammerDB, DVD Store, Slob. Yeah, there's a whole bunch of them. Right? And so pick your poison on that one. And then you can test that WAN configuration under load. And if you want to see what's my range, you replay your production workload and you just keep extending your latency out and out and out and out until it breaks. And then you know what your radius is for where you can go look for another data center, right? Or if you are dead set on 2 data centers, you can test that latency and ratchet up your workload until it breaks. And then you'll know, 1, does it work? And 2, if it does, how much can we scale before we have to make modifications to it? So you can do that for cheap with open source stuff or free stuff, as long as you have a decent amount of resources in your ESXi lab. All right.
Just in conclusion, so stretch clusters, we all know it's disaster avoidance, right? It's not disaster recovery. You don't need to stretch your storage and you need to stretch your network. We also showed how you can use Oracle RAC extended and traditional using vSphere cluster or vMSC and have Oracle Data Guard plus have business continuity as well. Marlin just went into how you can build your own POC for cheap, right? Test it out, test out your workload, test how long you can go far before you actually go and start shelling out those dollars. So in conclusion, absolutely. Do we have customers doing Oracle RAC on vSphere? Yes, I have a lot of customers doing Oracle RAC on vSphere. Do we have a lot of customers doing extended Oracle RAC on vSphere? Marlin spoke about Telecom Indonesia, right? Mm-hmm. First winter in Germany. So we have people doing all variations of Oracle, right? RAC, extended RAC, single instance databases on vSphere Metro Storage Cluster, and also on Virtual SAN. So absolutely, there should be no qualms in virtualizing Oracle databases on vSphere and deploying any of these configurations of vSphere as well.
Questions?
So these are some references.
Obscene gestures?
Obscene gestures, yes.
Obscene gestures, of course.
Could you speak a bit louder, please? Oh, there's a microphone there.
Oh, yeah, there you go.
Yeah.
You go right to the microphone there and everybody can hear you.
In traditional you have shared storage and multiple nodes are talking to that same shared storage. Over here, what you are telling is it's replicated. So each site is talking to its own replicated.
So think of 2 SAN.
That's correct.
Yes, that's correct.
Yes.
In that case, my question comes back to that disaster recovery part, DR part was saying that in site A, you have everything available on site B. So doesn't it serve as, doesn't it make standby redundant other than logical corruption? Other than that part.
He just spoke about physical corruption, right? So think of it. You have a pipe. That's your interconnect pipe. And these are 2 sides of the pipe, right? Site A, site B. I put a little garbage here. What comes out here? Garbage. Right? So basically, if you have physical corruption, that physical corruption... Sorry. The physical corruption goes across the wire from site A to site B, right? And that's why we say this is disaster avoidance. Let me finish, please. This is disaster avoidance. That's why we say for disaster recovery, Data Guard. Because Data Guard has that 0 block corruption, right? I can fix myself by looking into the production and vice versa. That's what Data Guard gives you.
Okay, I'll not use word DR, I'll say VCP.
Okay.
So in that case, if we are using the standby database for BCP purpose only, that becomes redundant. Is that correct?
If you're using a standby database for business continuance, right? Okay, and your standby is running on a synchronous mode? Your standby database is running on a synchronous mode, or is it asynchronous?
Say synchronous.
Synchronous mode. And you're able to swing your application from, let's say, site B to this using either DG, MGRL, or whatever, right? Data broker.
So wouldn't that make standby really redundant? We just cut up and have it running on site B?
Now, yes and no. There's one thing that you can do that kind of makes it, that grays the zone between disaster avoidance and disaster recovery. If you're using something like either flashback query or flashback database, right, on your rack, then, and something goes south, you get some physical corruption in there or whatever, you can flash it back, right, for whatever your window is for your flashback database. And so that kind of blurs the distinction a little bit. But it's still good to have your third disaster recovery site, so you can do a point in time recovery to it while you still have your production up and things of that nature. If you need for accounting, in fact, we had one instance where there was they found some less than honorable transactions that happened, and so we had to do that. We had to do a point in time recovery to right before the less than honorability started, so that we could figure out, forensically what was going on and all of that. And so that's always good to have your disaster recovery site for that kind of junk too.